Okay, checking 2-7. We are dealing with here either independent events, which is what we're dealing with in the first part, where we have two different die. And then when we get to number 15, we'll be dealing with dependent events. And so what you roll on the blue die does not affect the green die, but it is an and situation, so we're going to multiply. The probability of rolling a 1 on a blue die is 1 out of 6. With that and, I'm going to multiply. Probability of rolling a 1 on the green is also 1 out of 6, so we get 1 out of 36. The probability of rolling a blue 1 is 1 out of 6, and tells me I'm going to multiply. Green, I need a 1 or a 2, so that would be 2 out of 6. Let's reduce our fraction first, and that will give me 1 out of 18. Number 3, the probability of the blue being a 1 or a 2, that would be 2 out of 6, and the green being 1 would be 1 out of 6. Again, we can reduce our fraction, and we get 1 out of 18. Number 4, the probability that the blue is a 1 or a 2 would be 2 out of 6, and the green being a 1 or a 2 would be 2 out of 6. And again, that and tells me that I'm going to multiply. I'm going to reduce both of my fractions, and I am going to end up with 1/9. Moving on to number 5 with the same two set of dice, the probability that the blue is even, that would be 2, 4, or 6, which would be 3 out of the 6. And the green being even would be the same thing. So both of those fractions will reduce to 1/2. And so we end up with a 1 out of 4 chance that that happens. The probability that the blue or green is less than 6, so that's 5 out of 6, because 6 is not less than 6. So 5 out of the 6 sides on both die. So that would be 25 out of 36. Nothing cancels there. Number 7, the probability that both the blue and green are less than 7. Well, 6 out of the 6 on the blue are less than 7, and so are 6 out of 6 on the green. And both of these fractions will reduce to 1. So that's a sure event. You are going to roll less than 7 on both of those die. The probability of the blue being a 6 would be 1 out of the 6 sides. And the probability of green being a 7 would be 0 out of the 6 sides. There is no 7. So this is going to be 0, because anything times 0 is 0. And you actually end up with 0 over 36, which is 0. And then when you hit number 9, you says you have a bag containing 2 A's, 3 B's, and 4 6. You replace the first tile in the bag and then choose again, find the probability. So our total is 2 plus 3 is 5 plus 4 is 9. So we have a total of 9. That is going to be the bottom of my fraction. So in A, 2 out of 9, you put it back, there's still 2 out of 9. So we're going to get 4 out of 81. A and then B. A would be 2 out of 9. B would be 3 out of 9. Reduce that fraction. And we're going to get 2 out of 27. A B and then a B would be 3 out of 9 times 3 out of 9. So again, let's reduce our fractions. And we're going to get 1/9 when we multiply our fractions. A C would be 4 out of 9, and then again 4 out of 9. And again, this is assuming that you replace the first card, otherwise it's going to change. So we get 16 out of 81. B and C, so a B would be 3 out of 9, C would be 4 out of 9. Let's reduce our first fraction here to 1/3. And so we're going to get 4 out of 27. And then finally a C, and then a B. And we have the same thing that we had in the one before it. My fraction reduces, and I end up with 4 out of 27. Okay, in the last set, or second to last set, you select a card at random from these below. So it's the word probability on cards. So I didn't put little boxes around them, but that's what it would be. This is without replacements, so we're not going to put the first one back before we choose the second one. And there are 11 letters to begin with. And they do tell you at the beginning that you need to consider Y a vowel. So your vowels would be the O, the A, the I, and the Y. So the probability of choosing a vowel when we do our first pull is that there's 5 vowels out of 11. When we go to do the second pull, we have removed one of the vowels, so there's only 4 of them left, and we only have 10 cards left. So showing my reduction there, I can reduce that, and then I can also do 5 into 5. And so I will end up with 2 out of 11. A consonant, 6 out of the 11 are consonants. When I pull again, there's only 5 consonants left and 10 cards left. That will reduce to 1/2. And then this 2 will go into the 6 3 times. So I'm reducing those fractions. I end up with 3 over 11. Number 17, pulling an I and then an I. There are 2 I's out of the 11. Once I've pulled one, there's only 1 left and only 10 cards left. Reduce your fraction. And we end up with 1 out of a 55 chance. A consonant, which we said there were 6 of them out of the 11, and then a vowel. There are still 5 vowels because we didn't choose a vowel the first time we chose a consonant, but only 10 cards. So like a visual of that. If I chose a consonant first, let's say I pulled the P. So there's a 6 out of 11 chance that I get that a consonant. I pulled P out. Now there's only 10 cards left. 5 of them are vowels. So doing some reducing, and then 2 will go into 6 3 times. So we end up with 3/11ths on that one. Number 19, the probability of pulling an A. Well, there's 1 out of the 11 that are A's. If you pull that card, then there are no more A's left. And so you have a 0 out of 10. So that's going to be 0. And then 20, pulling a letter and then a letter. Well, 11 out of the 11 are letters, and 11 out of the 11, sorry, you've pulled one. 10 out of the 10 are letters. So that's just going to be 1 is what that's going to be. So you have, I wrote that down wrong, 4 girls and 3 boys that volunteer. And the teacher puts the names in a bag and draws at random. And it says, what's the probability that both representatives are girls? So there's a 4 out of 7 possibility that the first draw is a girl. And then if that first draw is a girl, then that means there's only 3 girls' names left in the bag, and there's only 6 people total. So this will reduce to 1/2. And then that 2 will go into 4. And so I end up with 2/7 on that one. Number 22, a refrigerator holds 11 drinks. You've got 5 lemon, 3 apple, and 3 orange. Abby is the first in line. Telly is second. What's the probability that Abby gets a lemon drink? That would be 5 out of the 11. And then Telly pulls an orange drink. Well, there would only be 10 drinks left when Telly goes up to pull. And 3 of those would be orange because Abby pulled a lemon. drink. So 5 will go into 10 two times. So we get 3 out of 22.